Meaning, is this linear? Is this a linear equation? Who says yes? Why is it yes? Okay, so you look at the variables, and what about the exponents? What are they? Huh? 1 is assumed. If there's no exponent, it's assumed to be 1. So it is linear because the variables y and x have what exponent?
So is that a 4 or is it 44?
That's negative 4y. So both exponents are what numbers? 1. So it's linear. We talked about that last time. In fact, everything we did last time was a linear equation. And it looked like this. Okay, so I want to do this, though, using a t-table. And this was similar to the very last problem we did in class. And on your worksheet, it's similar to the very last problem in your worksheet that you got. How are you going to do this problem? Divide both sides by negative 4, so you get y by itself. Okay, so I'm going to rewrite this over. Divide both sides by negative 4, just like this. What you do one side, you do the other. And then if you look on the left side, negative 4 divided by negative 4 is 1. 1 times y is y. Now, remember our discussion last time about the other side. How do you want to rewrite this other side? So you write it as two separate fractions. So you're going to say 3x divided by a negative 4 minus a divided by negative 4. Okay? And now we're going to rewrite this part like this now. You're going to say y equals, remember a negative divided by a positive, or positive divided by a negative is a negative. So 3x divided by negative 4 means the same thing as negative 3/4 x. A negative 8 divided by negative 4 is what? Plus 2. All right, so we have this equation. So what we did was, whenever possible, get y by itself. If you're using a t-table, get y by itself. Now, we also talked about the fact that if the coefficient of the variable x, when you get y by itself, the coefficient of a fraction, you want to be strategic with the x values. Since I have this fraction, what x values do you want to use? Use numbers that are divisible by the denominator. What's my denominator? 4. So what numbers are divisible by 4? 0, 4, negative 4, 8, negative 8, 12, negative 12, and so on. Now, when we did this using a t-table, how many numbers did I choose? 3. Easiest one to use is always what number? 0. All right, remember I have a fraction. We use numbers divisible by 4. So I'm going to say 4, and then what's the other one? Negative 4. All right. So now I got to find the y value. So if x is 0, that means I go to my equation right here. Where we see the variable x, what do you plug in? 0. So I have y equals negative 3/4 times 0 plus 2. What's negative 3/4 times 0? And 0 plus 2 is 2. So I have the point 0, 2. Remember what we were finding, and we talked about this last class period, what we're finding here are solutions. Those are solutions to that equation. There's an infinite number of them.
Was this graphic for us to do the review, or this for the new lesson we started today?
No, you can use that on there.
Okay.
If x is 4, you're going to say y equals negative 3/4 times 4 plus 2. Now remember, you go off to the side and you got to do the multiplication before addition, the order of operations. So negative 3/4 times 4 over 1. Negative 3/4 times 4 over 1. If you want to reduce first, you can. If you want to multiply first, you can do that as well. Does not matter. If you multiply first, you'd say negative 3 times 4 is negative 12. The denominators, 4 times 1 is 4. And then reduce, what's negative 12 divided by 4? Negative 3. So then this becomes negative 3 plus 2, which is negative 1. So I found another point in that line for negative 1. And the next one, x is negative 4. Wherever you see the variable x, I plug in negative 4. So I get y equals negative 3/4 times a negative 4 plus 1. All right, let's do this multiplication. I have negative 3.
Plus 2.
I'm sorry, thank you, plus 2. I have negative 3/4 times a negative 4 over 1, right? If I want to multiply first and then reduce, I can do that. First of all, a negative times a negative is a positive. So a negative 3 times a negative 4 is a positive 12. The denominator is 4 times 1 is 4. And what's 12 divided by 4? 3. So I get 3 plus 2, which is 5. All right, so I found 3 points. Now remember, to graph a line, all you need are 2. But when using a t-table, let's just use 3 just in case I messed up with one of the computations here. Because all 3 have to lie in the same line. All right, putting that on your graph paper. So you got those 3 points. All right, so I get 0, 2. So remember, you started the origin. Since x is 0, you stay there. Since y is a positive 2, where do I go? Up 2. Now, what I've done is plotted the point. Now, what does labeling mean? Because the directions you say label. Labeling means you actually tell me what those coordinates are. So this is 0, 2 with parentheses. The other point is 4, negative 1. So you start the origin. To plot the point 4, negative 1, you go to the 4, negative 1. Is that correct, 4, negative 1? So you go, 4 is positive. You go to the right. Go to the right. So you go to right 4. And it kind of makes sense because in that 4 right here, positive 4, negative 4 would be right here. So you go to the right 4, and then negative 1 means you go down 1. It kind of makes sense because this is negative 1 right here. To plot the point negative 4, 5, the next one's negative 4, 5. To plot the point negative 4, 5, you start the origin. Since x is negative 4, which way do I go? Left 4. And that kind of makes sense because that says negative 4. Y is positive 5, so y is positive 5 above the x-axis, so that's here, right here. See, on the y-axis, y is 5. So you go 5 units above the x-axis. So that's this right here, negative 4, 5. And then you use your ruler and you graph your line. And notice they all lie in the same, those 3 points lie in the same line. Now remember, you extend and you draw your arrows. And so this is the line, negative 4y equals 3x minus 8. All right. Okay, now, we started talking about intercepts. We started talking about intercepts last class period. And so let's kind of remember something we talked about. So if I draw a line, and let's say it does this. Notice that this line I just drew intersected the y-axis at this point, right? So that point is called the what? Y-intercept. So anywhere the graph crosses the y-axis, that point where it crosses the y-axis is called the y-intercept. Notice, though, if I ask you to label this point, what are the coordinates of this point right here? 0 what? 0 what? 7. 0, 7. What are the coordinates of this point right here? 0, negative 3. What are the coordinates of this point? 0, negative 6. So notice from our discussion from last class period that for all these y-intercepts, wherever the graph crosses the y-axis, what do you notice about the x-coordinate? The x-coordinate is 0. All right. So then we also looked at graphs that cross the x-axis. So if you look at this point where it crosses the x-axis is called the X Intercept. No matter where it crosses the x-axis, those are X Intercepts. What are the coordinates of this point right here? 8, 0. What's this one? 2, 0. What's this one? Negative 3, 0. So in terms of X Intercepts, what do you notice about the Y coordinates? Y coordinates are 0. All right. So if you look at your notes from last class period, on that, I think it's either the second last page or the last page, one of the things we wrote down, it's the last page, one of the things we wrote down was this. So Y-intercept is where the graph crosses the y-axis, and the X-intercept is where the graph crosses the x-axis. We also stated that the Y-intercept, x is what? 0, and the X-intercept, y is 0. All right. So we're going to use that idea with the next problem. Okay, so the directions, notice the directions on the worksheet you got last class period said use a t-table. The directions for this one is going to say this. It's going to say graph each linear equation So graph each linear equation using intercepts. All right, graph each linear equation using intercepts. All right, so number one, let's suppose this is our equation. We have negative 3x plus 2y equal negative 6. So negative 3x plus 2y equal negative 6. All right, now remember, the direction says, always follow the direction. Direction says using intercepts, doesn't say anything about a t-table. So you got to use the intercepts. The directions will probably also say this. Write the intercepts as an ordered pair. So write the intercepts as an ordered pair. So when we graph that first line, this one here, and we wrote negative 4, 5, 0, 2, 4, negative 1. These points are ordered pairs. So a pair meaning 2, right? And they're ordered because it's in the order x coordinate and then the y coordinate. So these are ordered pairs. So when you say when they ask you to write an ordered pair, they want to know what's the x coordinate and what is the y coordinate. So when we talk about an ordered pair, we're talking about x comma y. So you got to indicate what the x coordinate is and what the y coordinate is as a point. All right, so you want to use intercepts, meaning the x-intercept and then the y-intercept. Okay, so let's remember about something we just talked about. For every x-intercept, what did we say was 0? The y. Not the y-intercept, but the y variable was 0. So to find the x-intercept, you're going to let y equal 0. And so when I let y equal 0, so wherever you see the variable y, I plug in 0, notice what happens. I get negative 3x plus 2 times y, y is 0, equals negative 6. So wherever saw the variable y, plugged in 0. What is 2 times 0?
0.
So this is 0, so negative 3x plus 0 is what? So you got negative 3x equal negative 6. All right, now you don't have to do all this work. If you know that y is 0, then you all agree that 2 times y is 0, correct? So this term is 0, so it's kind of like if you cover it up, that's 0 right here. So all you see is what equation? Negative 3x equal what? Negative 6. That's all you see. But remember, you got to get x by itself. What's the coefficient of x?
Negative 3.
Negative 3. So right now I'm multiplying by negative 3. You always do the opposite. What's the opposite of multiplying by negative 3? Dividing by negative 3. So I'm going to divide both sides by negative 3. And then I reduce. Negative 3 divided by negative 3 is 1. 1 times x is x. So what is the x-intercept? Huh? 2. A negative divided by negative is a positive. 6 divided by 3 is 2. So my x-intercept is 2. Now remember, many of you are not going to remember all the directions very well, so you're going to put a 2 here, but that's not what I wanted. It is true that the x-intercept is 2. That's a true statement right here. But the direction said to do what? Rise in ordered pair. So you got to say parentheses 2 comma what? 0, because that's what y is. Y is what? 0. So make sure you put 0 in for y. All right, so you need to find the y-intercept now. To find the y-intercept, what is 0? X. So you let x equal 0. So if I let x equal 0, this becomes negative 3 times 0 plus 2y equal negative 6. But what's negative 3 times 0? And 0 plus 2y is just 2y. So get 2y equal negative 6. And then how do you get y by itself? Divide by 2. 2 divided by 2 is 1. 1 times y is y. So the y-intercept is negative 3. Now, you didn't have to do all this work. If you know that x is 0, you could have just gone right here. The term involving x is 0. So you kind of cover it up and you ask yourself, what equation do you see? Well, I see 2y equal negative 6. That's what this is right here. And then you divide by the coefficient and you're done. But as an ordered pair, how do you write this? 0 comma negative 3. All right, and so then you plot those 2 points. So 2, 0. Remember, you're plotting 2, 0. So you start at the origin. X is 2. So which way do you go? To the right. And then y is 0. So that means I stay there. So this point, remember, I'm plotting the x-intercept. So since the x-intercept, that point I plot better be on the x-axis. And it is. It's on the x-axis. So that's 2 comma 0. So you label your points. The next one is the y-intercept, and we said that was 0, negative 3. So when I plot that point, it better lie where? On the y-axis. All right, but it's 0, negative 3. So x is 0, so I stay at the origin. Y is negative 3, so I go down 3. So this is the point, 0, negative 3. And then you just use your ruler to graph the line, and you're done. All right, so that's the line for negative 3x plus 2y equal negative 6. Okay? All right, so let's look at the next one. So number 2 of this part, number 2, we have x plus 2y equals 6. All right, so again, you want to use the intercepts. And let's write the intercepts as an ordered pair. So I'm finding the x-intercept, and I'm finding the y-intercept. Again, to find the x-intercept, what do I say? How do I find the x-intercept? Let y be 0. So where we see the y, you substitute 0. So really, you can just cover it up. But remember, the reason you're covering it up is because 2 times 0 is 0. All right, so that's 0 right here. And so x is just equal to what? 6. If you want to do the work, you can. You would say x plus 2 times 0 equals 6. 2 times 0 is 0. And x plus 0 is still, what's x plus 0? X, so x equals 6. So you found your x-intercept. So the x-intercept is 6, but you need to write as an ordered pair, so you're going to say 6, comma 0. To find the y-intercept, you let x equals 0. So this time, if I cover it up, that says 0 plus 2y, which is just 2y. So you get 0 plus 2y. Again, if you want to do this work, you can. You get 2y equals 6. So how to get y by itself? Divide both sides by 3. I'm sorry, by 2. 2 divided by 2 is 1. 1 times y is y. So what's the y-intercept? 3. As an ordered pair, though, you're going to say, yep, 0, comma 3. Now, no one said anything wrong about this one. What should this have been? Oh, I'm sorry. No, I'm right. I'm right. Excuse me. I apologize. I was thinking we were finding the y-intercept, but this says x-intercept, right? Okay. All right. So that's fine. Okay. All right. Now we plot that point, or those 2 points. So the x-intercept, your point is going to lie on the x-axis. The y-intercept is going to lie on the y-axis. All right, so 6, 0 is here. And then 0, 3 is on the positive y-axis. And then you draw your line and you're done. Okay? So that's the line x plus 2y equals 6. All right, so number 3. Number 3, suppose we had this. Y equal 3x. Y equal 3x. So again, I want to do this by using by using the x and y intercepts. X and y intercepts. So x-intercept and y-intercept. Okay. To find the x-intercept, what do? I let y equals 0. Now notice, you got to be careful sometimes because you're going to cover it up and you're not going to know what to do. You're going to say, well, all I see is 3x. Well, you see a little bit more than 3x. You see 3x equal what? 0. That's what you see. All right, you see 3x equals 0. So remember, you're letting y equal 0, right? So 0 equals what? 3x. That's what you see. So we did the others. If you recall, when I found the x-intercept, I let y be 0. So I covered up, and really all you saw was x equals 6. That was kind of easy to deal with. But it was x equals 6 because x plus 0 is still what? X. That's y. But how do I get x by itself? Divide both sides by 3. What's 0 divided by 3? 3 divided by 3 is 1. 1 times x is x. So I found the x-intercept. The x-intercept is what ordered pair? 0, 0. But 0, 0 sounds familiar. What is 0, 0? The origin. That's the origin. Remember, that's the point where the x-axis and the y-axis intersect. All right. So let's find the y-intercept. To find the y-intercept, what do? You let x equals 0. All right, well, let's think about this. Let's do the long way. If x is 0, I get y equals 3 times 0, right? But what's 3 times 0?
0.
All right, but I want you to think about it. You really didn't have to do all this work because it says you let x equal 0, correct?
Yeah.
Well, look, x is already 0 here, so what must the y then be? 0, which is what this says. The point being this. If your origin is the x-intercept, then that's also the y-intercept. So notice, though, when I plot those 2 points in the coordinate plane, they're not 2 different points. They are the same point. That's the origin. So the graph crosses the x-axis and the y-axis at that point. So the x-intercept and the y-intercept are the same point. But how many points do I need in order to graph this line? I need 2. I only have 1. So in my math, and there's going to be one like this in my math lab. So in my math lab, there's going to be an additional direction that goes with this one. It's going to say if the x and the y-intercept are the same point, then find one more point on the line. How many points are on this line that I need to draw? No, how many points are on it? An infinite number. All I know so far is how many? 1. Okay, so remember I'm looking at y equals 3x. So if I want to find another point, just one more point, then what can I do? Plug in a number for x. Remember that t-table? Plug in a number for x. So you're just going to say let x be, let's say what? 1. Okay. If x is 1, I get y equals 3 times 1, which is just 3. What else could someone have said? There's an infinite number of x values you could have chosen. Give me one more. Huh? 6 would be too big. When I say too big, what's 3 times 6? What's 3 times 6? 18. It doesn't fit in here. So try and use numbers that fits within the grid. So 3 or negative 2 does not matter. If you want to use negative 2, you'd say y equals 3 times negative 2, which is a negative 6. But I just need one more, right? Okay. So if you chose 1, 3, you go to the right one, up 3, and then you draw your line. If someone else had chosen negative 2, negative 6, notice it does not matter. It does not matter what point you use negative 2, negative 6. Does not matter. It should be this one. Does not matter which point you use, it will all lie in the same line. All right. So there is one on my math lab where when you find the x and y intercept, it's the same point being the origin. So you just find another value for x, plug in for x, and you get your y value. But let's discuss why in these cases, right here, when we found the x and y intercepts, they were different. See, that one and that one are distinct. When we did this one, right here, the x and y intercepts are different. Same thing here. When you look at this one, the x and y intercepts are different. They're not the same. But here, the x and y intercept are the same. So what do you think if you look at the equations? If you look at those equations, these three equations, and compare it with this one, what's different?
The number is missing.
Okay, so he says a number's missing. Yeah, I'm assuming you mean like a -6. What is that term called right here if it's just a number, no variable? You remember what that term's called? Huh?
Constant.
Constant. So here you have variable terms. These are variable terms because it has a variable in it. This is a constant, so that stays the same. That's always a -6. So this has a constant. So notice two different intercepts. This has a constant other than 0. Notice two different intercepts. This has a constant 6, two different intercepts. But this way you don't see a constant. You see two terms, and they both have, right here. You see two terms, and they both have variables in it. So that constant, there is a constant there. It's understood to be 0. So y equals 3x plus 0, something like that. Okay? So it's something other than 0, then you'll have two distinct intercepts. If there's no other constant there, if it's just y equals 3x, no constant, the intercepts are the same. Okay? All right, so there is one in my math lab that looks like this. So when you do it, you're going to notice that the x-intercept and y-intercept are the same, so you just find one more point. And basically you do it just like this. Okay? All right, let's look at number 4. Number 4, suppose we had this. Y equals 2x minus 8. Based on what we just talked about, will the x and y intercept be the origin? Yes or no, real quick?
No.
No, because you see a constant. Constant is -8. So the x and y intercepts will not be the origin. And it kind of makes sense because if I let x be 0, what do I get for y? Not 8, but -8. All right? Okay. So let's find the x and y intercept. X-intercept, Y-intercept. Okay, to find the x-intercept, you're going to let y equals 0, and to find the y-intercept, you're going to let x equals 0. I'm going to do the y-intercept first. That one's easier to figure out. If I let x be 0, I'm going to cover it up, and notice that I put a 0 on my fingernail. So that's 0 and a -8 is just what? -8. So the equation you see is y equals what? -8. Now, if you want to do the work, you can. You would say y equals 2 times 0 minus 8. What's 2 times 0?
0.
And 0 subtract 8 is a -8. So I found the y-intercept as an ordered pair, though. What is it? 0, comma, -8. All right. Now remember when I covered up, what you saw was a 0 right here. All right. Now for the x-intercept, you're gonna let y equal 0. Now if you cover it up, some of you are gonna have an issue. You're not gonna think about what you need to do. You're gonna say, well, I see 2x minus 8, but I don't know what that equals. Yes, you do. 2x minus 8 equals what? 0. When you cover it, when you're covering the term up with your thumb, that's really a 0 that's there. So what you may want to do is actually write it out. So if y is 0, then this becomes 0. So you say 0 equals 2x minus 8. But you got to solve for x now. So what's the next step? I wouldn't do that yet. I'll always do division last.
You're going to
Add 8 to both sides. I would do that first. Now, divided by 2 is mathematically correct, but I would do that last. Combine like terms with 0 plus 8. And then -8 and 8, 0. So what's left over here? And now divide by 2. So 2 divided by 2 is 1. So now I found the x-intercept to be 4. Again, if it did not say anything about an ordered pair, if the directions said nothing about an ordered pair, then you can just say 4 here. The x-intercept is 4. That's fine. That's a true statement. But the directions did say write the intercepts as an ordered pair. So you have to say parentheses 4 comma 0. Why would that be a negative 4? Why would that be a negative 4? Who asked that?
I did.
Okay, why do you think that would be a negative 4?
Looking at it's negative 8 to start.
Well, you add 8 to both sides, though, right?
To
So the negative 8 on the
yeah, I took the wrong path.
Okay.
I did it on my own, that's right.
All right. Now, if you had, I'm not sure if you did this, if that's what you did, but remember how we added 8 to both sides? Someone else could have subtracted 2x from both sides. Does not matter. You could have done that. You get 0 to negative 2x is what? Negative 2x equal, these cancel out. What's left? Negative 8. But then to get x by itself, you have to divide both sides by negative 2. Negative 2 divided by negative 2 is a positive 1. 1 times x is x. And then remember, a negative divided by negative is a positive. 8 divided by 2 is 4. So you get the same thing. All right, so now we're going to plot those points and graph the line. All right, so plot those points, graph the line. So you get 4, 0, which is on the x-axis. It has to be because that's the x-intercept. 0, negative 8, that's the y-intercept, so it has to be on the y-axis. And then you draw your line. And you get this. Okay? So that was the equation y equals 2x minus 8. All right. Let's look at number 5. For number 5, suppose we had this. We had y equals negative 4x plus 6. Y equals negative 4x plus 6. Again, you want to use the intercepts. So you want to find the x-intercept. And you want to find the y-intercept. Again, to find the x-intercept, what do? Let y equals 0. To find the y-intercept, you let x equals 0. Find the y-intercept is the easiest one to do in this case. So let's do that one first. If I let x equals 0, do y'all agree that when I covered up that 0 right here, that x term?
Yes.
So what do you see that's left? Y equal what? 6. So if you want to do the work, you can. You'd say y equals negative 4 times 0 plus 6. So that's 0 plus 6, which is 6, right? So there's your y-intercept. As an ordered pair, you're going to say 0, 6. All right, x-intercept. All right, now this time, remember we just talked about if I let y equal 0 and I cover up that term, don't let that confuse you. The equation you see is negative 4x plus 6 equal what? 0. That's what you see. You see a 0 there. So when I let y equal 0, this is a 0. So I get 0 equals negative 4x plus 6. All right, think about what we just did. So what's the next step? Subtract 6 from both sides. And combine like terms. 0 and a negative 6 is a negative 6. Negative 6 and positive 6 is 0. So you're left with negative 4x. And then to get x by itself, you're going to divide both sides by negative 4. Negative 4 divided by negative 4 is 1. 1 times x is x. All right, now remember, negative divided by negative is a positive. Now, the difference between this one and all the others is that all the others, you ended up with integers. Here you're going to end up with a fraction. If I reduce it, though, what fraction do you end up with? 3 halves. 3 halves, right? Okay? Now, just remember, let's kind of remember something. 3 halves, is that a proper or an improper fraction? Improper. So since the numerator is bigger than the denominator, that's improper, meaning that you can write this as a mixed number. So that's improper fraction. And you can write as a mixed number. So when you plot, if you have an improper fraction or any fraction, you got to estimate where it is, where it's located. So that's 3 halves. 3 halves as a mixed number, remember how to find the mixed number? You take the denominator, divide into the numerator. So you're saying 2 divided into 3. 2 into 3 is 1. 1 times 2 is 2 with a remainder of 1. So the numerator, this quotient, is your whole number unit. So you're going to say that's going to be 1, 1, and 1 half. So 3 halves as a mixed number is 1 and 1 half. And remember, you can always check yourself. You take the denominator, multiply the whole number part. 2 times 1 is 2, and then add it to the numerator, and you get 3. And that's what this. Then this is what this is right here. So writing as a mixed number helps. That's what you want to do. And there is one on your worksheet like that, where you're going to get a fraction. And there is one on my math lab. But writing as a mixed number helps you to find where that point is in the coordinate plane. So when we write the x-intercept as an ordered pair, it does not matter whether you say 3 halves comma 0 or 1 and a half comma 0. It does not matter. Okay? For those of you, though, that wrote it as 3 halves comma 0, when you go to plot that x-intercept, you still need to say it as what, though? 1 and a half. So when I find the x-intercept, I'm going to say 1 unit plus a half, right? So 1 and a half comma 0 is in the middle of 1 and 2. All right, so there's my x-intercept. So that's 3 halves comma 0, or you could have said 1 and a half comma 0, does not matter. The y-intercept is 0, 6. So that's here. And then you draw your line. But there is one problem in the worksheet, and I think there's 1 or 2 in my math lab with the fractions. But don't forget to write a mixed number. That's the way you do that. All right, so that was y equals negative 4x plus 6. Okay? All right, one more. Now, the one we're about to do is a little bit challenging. So, when you do the one on the worksheet, or my math lab, make sure you use this as an example. Make sure you use it in front of you as you do it. So here's number 6. Y equals negative 3/4 x plus 3. Y equals negative 3/4 x plus 3. All right, first of all, is it easier to do this problem using a t-table or using intercepts? A t-table. You get this a lot quicker just using a t-table. Because in a t-table, you let x be 0, and then remember, you got to, since the coefficient of x is a fraction, choose numbers that are divisible by 4. So 0, 4, -4, and in 30 seconds you're done. So T-table is the easiest to use here, but you got to follow directions. Direction says use intercepts. So let's use the intercepts. So we have to find the X-intercept and then the Y-intercept. And again, to find the X-intercept, you're going to let y equals 0. To find the X-intercept, you're going to let the Y-intercept, sorry, you're going to let x equals 0, right? Think about which one's going to be easiest to deal with. Which one's easier to find right away? The X-intercept or Y-intercept in this case? The Y-intercept. Because if I find the Y-intercept, I'm letting x be 0, which means that this term is 0, right? So y equals what? Which is 0 plus 3 is not 0. 3. Okay, so y equals 3. So there's your Y-intercept. So the Y-intercept's easy for this one. But the X-intercept is not as easy. All right, so let's talk about the X-intercept. Now you gotta listen carefully to our process. So if I let y equals 0, this term is 0, right? So I get 0 equals -3/4 x plus 3. Y'all agree? All right. Now we had this situation a while ago, and let me find it. Let's see. Okay, it's right here. All right. So when I look at this one, when I compare this one and this one right here, where I had -4x plus 6 equals 0, why was this one easier to solve for x than this one is? Why do you think? I said again? Okay, so you say no denominator, meaning that one you can see a fraction and the other one you don't, right? Okay, so the one with a fraction is going to be the more challenging one to deal with. All right, but we're going to use the same idea though. What I did first was got rid of this constant. So I said I'm going to subtract 6. So here I'm going to do what? Subtract 3. Okay, so I get, and then I combine like terms, 0 subtract 3, 0 and a -3 is a -3, equal 3 and a -3 is 0. So what's left on this side? -3/4 x? All right. Now, we're not going to have time to do it both ways. I'm going to do it the other way next class period, but here's the way we're going to do this one. You got to listen carefully. And it's a little bit easier for some of you because many of you don't remember how to divide fractions. So do it this way for right now. Do y'all see that this right here? Do y'all agree, first of all, that -3/4 x, just like this, is the same thing as, say, -3x divided by 4? Y'all agree?
Mm-hmm.
Okay. So do you see that I'm dividing by 4?
Mm-hmm.
What's the opposite of dividing by 4? All right. So it's multiply by 4. So right now, you see I'm dividing by 4, right?
Mm-hmm.
So I'm going to multiply. Let me write it over. So I'm going to multiply both sides by 4. What's 4 times a -3?
-12.
-12. You see this right here that I'm circling? I have 4 over 1 times -3/4. Y'all agree that this is this? That this is this?
Yeah.
All right, so I can reduce first or I can multiply first. Doesn't matter. We've dealt with this before. 4 times -3 is -12. 1 times 4 is 4. What do I get? -3, right? And it still makes sense because if I were to reduce first, the 4's divide out, what do you have left? -3. So do you agree that's -3x right here? Okay, so -12 equals -3x, and then finally divide by what? -3. So you found your x-intercept. What's the x-intercept? 4. X-intercept is 4. So let's kind of review. So right here I'm gonna put 4, 0, right? Before we plot the points, let's kind of review another one like this. I'm not going to do the whole thing. I just want you to tell me what to do. Suppose I had this instead. I had -8 equals -2/3 x. Let's say I had that. -8 equals -2/3 x. Using what we just talked about, what to get x by itself, using this procedure right here. What are you going to do first? Multiply both sides by 3. Let me go ahead and just rewrite this over. Because right now I'm dividing by 3, right? Okay, so times 3 times 3. So what's this right here? -24 equal. And then y'all agree that these 3's divide out? 3 into 3 is 1, 3 into 3 is 1. So what's left though? -2x, good. And then finally divide by -2. So -2 divided by -2 is 1. 1 times x is x. So what's my x-intercept in this case? Positive 12? Okay. All right. So that one is easier to deal with, but in the last class there was 1 or 2 students that wanted to do it the other way. And in terms of time period, I don't have time to do that, so I'll do it next class period. But let's just quickly plot those 2 points, draw the line, and we're done. I need to give you the worksheets though. So I have 4, 0 is here. 0, 3 is here. And then you graph your line. And that's it. There's your line.